Welcome to our Bridging the Divide summer series and our webinar on research lab safety. I am Cheryl Hall, the 2023 UL System Content Expert in the area of research and grants. Presenting this morning is Dr. Jean Fotie, Professor of Organic Chemistry at Southeastern Louisiana University. Dr. Fotie has been at Southeastern for about 15 years and is the holder of the Edward Schindler Endowed Professorship in Environmental Studies and Sustainability. Additionally, he is a scientific advisor for the International Foundation of Science and has served as a member of the Science Advisory Group of Louisiana Governor's Climate Initiative Task Force. Dr. Fotie will present this webinar this morning, so sit back and open your minds to receive the information. If you have any questions or comments, please place them in the Q&A. So without further delay, I turn it over to Dr. Fotie. Dr. Fotie?
Thank you, Dr. Hall, for the kind introduction. Thank you, everybody, for being here today. As she said, Dr. Hall said, I'm a Dr. Fotie. I'm here at the Department of Chemistry and Physics at Southeastern Louisiana University. And I will be presenting to you today, and I'm very happy to be here for this University of Louisiana System Bridging the Divide summer series. I will be talking about how to keep the lab notebook. I'm going to quickly say that when I was told I would be talking about research safety, I didn't think about the lab notebook. The lab notebook was not any of the thing I thought of. I actually thought about, chemical, about how rating the chemical, how to set up experiment, how to protect yourself. I talk about accident and all those kind of things. So like many scientists, I don't think we usually see a lab notebook as a part of a safety. Now that I started looking and do my research into this, I'm like, we should actually have considered this other aspect of lab notebook. We love our lab notebook for the documentation, to document our experiment and all those things, and we really keep it dear to us. But I think the safety part of that document should also be kind of taken into consideration. And I'm hoping that the information I was able to gather through the research I did when I was putting this together will help us kind of look at it from a different perspective. So the overview of what we talked about today. Let me see mine. Let's see if my presentation is, for some reason, it's not moving. Let's see if I try here. Okay, maybe it's, here we go. So it's moving. Let's see again. Yeah, then we're back. So in the overview of this presentation will be just kind of looking into generality of a lab notebook, pretty much what is lab notebook, how to select lab notebook, because we have different kind of way to document experiment in the lab. How do you select your lab notebook? What are the advantages and disadvantages of selecting one type of lab notebook over the other one? And because lab notebook is where we document things, we should be able to actually identify in which lab notebook what was written. So we should be able to have a system to label the lab notebook so that we can actually find them when we need them, or easily recover the information when we need the information. So we're also going to talk about what should be in the lab notebook. What are the things we actually put in the lab notebook? And then let us look at who actually owns the lab notebook. When we finish writing into the lab notebook and all that, who does that belong to? And after that, we look at lab notebook ethics. What are the ethics associated with having a lab notebook? Because I'm going to show you that as soon as you actually put information in the lab notebook take a dimension on its own. You no longer have complete control over what you wrote in your lab notebook. So those are the things, when we're writing them down, we usually do not look at that aspect, but as soon as we finish writing things in the lab notebook, it takes a life of its own, and that's something I would like to point out. And then at the end, I will kind of give us a brief summary as for what we talked about, and those a couple of tips and things that we have to kind of consider when we're playing with the lab notebook. But before I go through this, I just want to actually acknowledge that the information I will be showing you today, I gathered them from four major sources. One of them was a guideline for keeping a lab notebook from Rice University. They have a page where they actually showed GHDL, PI, how the lab notebook should be kept and all those kind of stuff. The other one is to keep lab notebook from science, from the American for Advancement of Science, American Association for Advancement of Science. The other one is a tutorial from Columbia University, how to keep the lab notebook. And the other sources I also used for this presentation was Guide to Keeping a Lab Notebook from the NIH. So these are the major four sources I use for this. As I go, every time I will borrow an information from a source, I will make sure that we know which sources I use for that information. But most of the one I will be presenting here come from those four primary sources. So what is the lab notebook then? Basic lab notebook, as we know, it's where we record the procedure, where we record the information, the region, the data, the calculation, sometimes the thought we have when we're going through the experiment, the explanation that we have, and most importantly, the result of the different experiment we actually set up. So that's pretty much what the lab notebook is. In whichever form your lab notebook should be, your lab notebook should have those kind of information in. When someone pick up the lab notebook, in fact, that's what they're looking for, those kind of things you put down when you're actually running an experiment. Then we will actually, it's also the legal document I will see to protect or to actually support intellectual property or to defend yourself or prove your innocence in case of accusation of fraud. So basically, it's not just where those information are, it's also a supporting document for other things. So as we put our lab notebook together, we should also be really aware of those other aspects of a lab notebook. But as scientists, we always see the lab notebook as a knowledge for future researcher. That's the first thing come in mind when you're a scientist. When you look at your lab notebook, you're like, hey, somebody in the future will look at this. But for most part, that future researcher are usually, for most part, people that will join the research group that you are in. So 99% of the time, the people that read your lab notebook are the researcher that joined the lab, either when you're still in the lab or when you're long gone. Those that are going to continue the research you started are most of the time the people that are going to read that lab notebook. So that's what many scientists see when they actually putting together a lab notebook. But we shouldn't forget also this aspect that it's a support document for thesis. So if you're a graduate student, that's where at the end, after 4 years, that's where you're gonna pick up everything you have been doing. And it's not easy to remember things you have done for 4 years. So you need to have a solid documentation where you could actually go and gather information to put together your thesis. And for broader dissemination of your research, that's also the support document for publication. So many publications and most of the publication, even if the draft is set up by the student on the bench, your PI also have to go in that book to actually look at the information to finalize the paper. So because the PI rarely is on the bench, it should be set in the way that everybody picking the lab notebook can actually easily have access to the needed information for those different aspects that I just put out there. So those are the things that the lab notebook should be used for, at least primarily used for. So I'm gonna just point out something here. And when I was preparing this, I just thought about this story as I was in the university. No, I wasn't in university, but I heard this story time and time again, the discovery of HIV. I just want to kind of show you a case where the lab notebook was at the middle or the center of a diplomatic crisis between France and US. So I just want to point it out so that you can see what dimension a lab notebook can take before we go into different type of lab notebook. Around the 80s, this disease show up, as we say, called AIDS. And many researchers will quickly, just like for COVID, everybody want to know what's going on. At the time in France, there was this professor called Luc Montagnier, who actually published a paper showing that they have this lymphadenome, I cannot even read the word, but LA virus. They isolated from people which were at risk of AIDS. And remember, when you're infected with HIV, that's when you're at risk for AIDS. So HIV is a virus responsible for AIDS in the case. So that group published in 1983 that they discovered this virus isolated from these people. At the same period in United States, there was a professor called Robert Gallo who was working for the National Science Foundation. He also published around 1984 a series of papers showing that they also have a virus that they believe is responsible of AIDS. The problem was that now who was the person that actually discovered the virus? And that became really a problem. And US and France was fighting, as I'm going to show you in a couple of slides, to actually attribute the discovery to one of those two people. Unfortunately, in the mix of that fight, this guy, John Critson, who was an investigative journalist from Chicago Tribune, published a paper he published a newspaper or a news article suggesting that Professor Gallo might have misappropriated the sample of HIV isolated from France. That could not be the worst time for Professor Gallo when you're actually trying to assert your property over the information. Just somebody come out and say it's not even you. You're now accused of misuse. Just not be the author of your own publication. You're accused of fraud and all other cases. So I'm going to show here what was kind of few things I gathered. And this is a page I borrowed from the New York Times at the time, when in 1987, the title was US and France and the Drift on AIDS. In 1987, they actually agreed that both scientists should be actually recognized as the inventor or those people that discovered the virus. So they was going to divide it between the two. So, and that was not just something that the two lab or the two PR sat down and discussed. No, actually President Reagan and the French Prime Minister at the time, Jacques Chirac, had to be involved. They actually meet to actually discuss the problem. So now I'm just showing you what dimension a data from the lab can take. It actually can become a diplomatic crisis between two major countries. So that was something someone just did in their own research lab without even knowing that one day this thing gonna become a huge, huge issue. Now, the major thing with that is that in 2008, when the Nobel Prize is attributed for those people discovering the virus, Professor Gallo was not mentioned he was not mentioned in the Nobel Prize when Montagnier was actually acknowledged in the Nobel Prize and was part of those that received the Nobel Prize. And many people speculated that Professor Gallo's reputation was damaged, although all the investigation by the NIH and other independent group showed that he didn't do anything wrong. It was clear from any wrongdoing. The Nobel Prize never mentioned him in any of the attribution. So I cannot sit here and tell you what happened. I'm just pointing out the fact that he never received the Nobel Prize for something that he has a series of papers on. And it was a drama. It was such a drama that this guy, Randy Schaefer, actually wrote the novel on that called And the Band Plays On. And this novel was actually turned into a series around 1993 on HBO. So if you're interested, you can actually watch the series in which Professor Gallo is actually very, very poorly, how will I say, portrayed. He's actually portrayed as a scientist, which is not very serious and things like that. I cannot testify to that. I'm just just putting out a couple of information I gathered, and actually watched a series some times ago, and I think as a scientist, it's probably a series that was watching if you're actually interested to know what happened at the time. So that was just a piece of information to show you how easily a lab notebook can turn into something really, really serious. So when we are writing things in our lab notebook, we should keep in mind that these things gonna maybe one day become a huge thing where everybody gonna scrutinize, and then you're gonna need it maybe for publication, you're gonna need it maybe just to defend yourself, you may need it to assert your property over a discovery, you might actually need it to end a crisis between two countries. So that was a point I actually wanted to make when I pick up this drama to kind of present it to you. So let us return then to lab notebooks. What are the kind of different type of lab notebooks you can use? The first one that we really used to, the one that's still the go-to, it's actually the physical lab notebook, the one, the stitch, the book, the bounded one that we keep in the lab, the paper one, and that's the one many people still use. And the reason behind that is that the paper lab notebook has, well, I went back. It's actually a hardcover stitch paper lab notebook has a number of advantages that the numbers, most of them, the pages are come numbers. So basically, which means that if you take up a page, someone would know that the page was took out from the lab notebook. That's one of the advantages. It's difficult to easily remove it. You have to actually tear it up, which will be intentional. You cannot just accidentally lose the page in the lab notebook. And then and you're gonna ask, why is it important? Because the authentication of the lab notebook, when it comes time to it, this is the most easily to authenticate when it comes down to look at the info, because everything is there in reading in real time, and nobody can actually add anything or subtract any pages without being actually noticeable or visible to everybody that the page was removed. So it's durable. So you can keep that for a very long time. So if you start it well, then you can have it for a very, very long time. It has its own disadvantages that we're going to talk about later, which is primarily that when you write something down, it stays there. So because the discovery is not always sequential and follow each other in the order we would like, it's usually difficult to have everything neatly organized the way you want. And that's kind of the drawback of the lab notebook. Because you discover something today from the experiment you set up like 2 weeks ago, it's difficult to go back to that 2 weeks ago because you have a full page and put that information in. So sometimes those information are scattered into the lab notebook. But even with that, it still make it a very good place to find information. It still make it a very good way to collect your information. I'm going to show you here a couple of examples of lab notebook from great inventors like Leonardo da Vinci. You can see how elaborate this lab notebook look with pictures and graphics. It doesn't have to be neat to be a good lab notebook. Even if Da Vinci is known primarily for his artwork, he was actually a good inventor, futuristic inventor. If you're a chemist, you might remember Mendeleev, who is the father of pretty much the periodic table. You can see that they have a very well organized lab notebook where everything is well written there. Marie Curie, we know Marie Curie was the first lady to get a Nobel Prize and still the only one with 2 Nobel Prizes. And you can see her lab notebook look very, it might be messy, but for me as a scientist, I think it looked very elaborate because you have pictures, you have diagrams, you have everything you might need. So for somebody like, what are you doing with that? But when you look at that, you're like, wow, there's a lot of things in there. And Thomas Edison, that really doesn't need any introduction. He was actually a great inventor. And you can see that having a lab notebook was where they kept the information. You see, they make it really clear what they're doing. They make it elaborate so that when you look at it, you know exactly where they're up to. If you sit down, read it, you will find any detail, all the information, anything you need to actually get to the information they were actually trying to get, or at least know what worked and what didn't work at the time they were running those experiments. So that's a couple of examples of hardcover physical lab notebook from great inventors that we actually grew to know. So lab notebook identification. If you have lab notebooks or in the lab, how should you treat your lab notebook? Make sure that your lab notebook are easy to identify. Who wrote in it? Who was the author of the lab notebook at the time? Make sure that that's easily identifiable. Make sure that the data in each of the lab notebook can easily be cross-referenced. Like if I'm running, if I look back there, I have a bunch of lab notebook. Sometimes a student will come to now, I'm running this experiment, it's not working. Like, but we have that experiment work before. So I should be able to jump there, pick up a lab notebook and be able to find that information and say, hey, this is how that experiment was set up before. Please go back and try to reproduce this one first and see how it goes and go from there. So how do we do that? What are the couple of ways you can make sure that not only your book, your lab notebook is easily identifiable, but that you can easily cross-reference information that you have in the lab notebook? The all the information or the reference I read preparing this actually suggests that we should use initial or names of a researcher, name of the project, or unique code to identify lab notebook. So we should actually have each lab should have a specific way to kind of label the lab notebook, but it should be consistent, it should be clear, it should be easily accessible. So whatever system a lab use, it should be something that anybody that get there could actually get used to the system. I'm going to pick an example. In the teaching lab, this is what we actually kind of ask them to do. When you comes in, we want you to have that little sticker in your lab notebook, or sometimes if you pick a composition book, luckily they already have that for you. So you just have to fill it up. You put your name, you put the lab you're going to be taking, you put the name of a professor that going to be teaching, you put a semester, you put a year. So basically that lab notebook already has enough information to be able to identify who had that lab notebook, what the lab notebook was for, and what classes they were taking, and what year and what semester and things like that. In the lab notebook, sometimes we do not do it exactly that way. We actually, this is an example from my own lab. We use codes. Like here we have TOS book 1. We know exactly what TOS is, and we know that that's a first book for that experiment, and that we know that in that book, because that's an old book from my lab, the only thing I'm going to find in there is TOS, and that's just the first book of TOS. If we have several experiments in the same lab notebook, you're going to see like in the second lab notebook, we have sticker on top of the lab notebook. The first one probably was for GSSO series. The second one was for CFPD series. And we know exactly what CFPD series is. We know exactly what GSO series is. So when I pick up that lab notebook, I know exactly what information I'm going to find in. And I'm going to show you that although on the back of the book, we don't know who you wrote in the book. In the first page inside the lab notebook, we know exactly who was writing in the book. We know exactly what period they were using the book for. Everything is actually clearly identified when you go inside the book. But we make sure that from the upside page, you can actually easily figure out which lab notebook you're trying to pick up. So that's the idea right there. The Columbia University actually have this recommendation for people for their lab notebook. They actually want you to have your lab notebook labeled on the cover and on the spine of the lab notebook. And I understand why, because you put it in the shelf like you put in books, and you should be able to come and pull one and know exactly what you're looking for. And of course, the information on the cover are exactly the same as I was saying. They use a code here, code AB, like I was saying, TAILS or GSSO, where the lab know exactly what those code means. And then they also have the name of the scientist, and they tell you which book which the serial book, but in this case, book 2. And then they said the lab notebook was used from February 2010 to January 2011. So that's actually the idea, how to actually rank or identify your lab notebook, how to label them. And of course, like I said already, if you have multiple lab notebook, it's a good idea or a good practice to actually kind of number the lab notebook so that you can know which is which. If indicate the date in which a lab notebook was used, we talked about that already. Always pick a period, those things are known after the lab note, that lab notebook is full. So at the end, when a student bring the lab notebook, so if the PI or the student themselves can do that, but if the student did not do that, the PI can easily do that and label the period where the lab notebook was used. Then, if the lab notebook is specific for one project, of course, we already said, please put the project on the cover of the lab notebook so that everybody can know exactly what was in that lab notebook. What should be in the lab notebook? So that was basically, and here notice that I focus specifically on physical hardcover lab notebook because it's still the one we use primarily. What if you're going to, the other type of lab notebook we're going to use, we're going to talk a little bit later about digital lab notebook. I'm going to kind of talk about that on a separate spot. But the other thing people can do is, and some people have done, is to use a binder as a lab notebook. You pick loose leaf, you put it in the binder, and you write and you put page after page. This lab notebook, that kind of lab notebook is not very recommended because for a ton of different reasons. First, the first one is just that it's very difficult to authenticate. Why? Because a page can be put in at any time. People will say, yeah, you can rewrite things, you can make it neat, you can organize, and that's true. But that very advantage is the same disadvantage of later when you're trying to authenticate, because you can put things in at any time. There's no guarantee that you put it at the time you're saying you did. Or sometimes you can just, let's say you're perfectly honest and everything, by accident, a page can completely disappear. You might be opening it to pick up something, and usually, and since several people tend to use a lab notebook, not every person is as careful as the person that put the data in. Somebody might pick it and then come back, or the page can later get teared up. We all have a binder where the paper just tear up on their own. So it's not very recommended to use that, although people think it's actually cleaner when you use it. But the lab notebook doesn't need to be that organized or that neat to actually serve the purpose of a lab notebook. So I was just going to point that out. And I will talk, as I said, I will talk about digital lab notebook a little bit later, because it has its own way to do things kind of different from those two type of lab notebook. But regardless of the lab notebook you select, the content should tend to be kind of the same. So the idea here is, what should be in the lab notebook? What are the things that you put in the lab notebook? Well, as I said, in our lab, we try to use the insert cover first to put a couple of information. Why not on the back cover? Because they can erase, you can have a spill, and then those things can kind of, get removed. So we tend to put the period where the lab notebook was used inside the cover, right there inside the cover. When you open the first cover, you find the period where the lab notebook was used, the project name, the clear project name, not just the code at that point, but actually the project itself. We tend to put, the address of the lab, which lab was, or the office, and then we tend to put the table of contents, and then we make sure that each page of the book is numbered and dated if they were not. So when you open the first page of the lab notebook from our lab, it will tend to look something like that. You will have like the lab of organic chemistry, we have the university, we put what our building, our address, we're going to put what the project is in there. Here is just a fake project. We're not doing any of that in our lab for sure. We're not doing zinc nanoparticle. I just pick an example to show you exactly how we actually keep the first page inside cover our lab. We put the period, and generally, as I said, I do that as a PI. When the student bring the lab notebook and say, hey, I'm done with this lab notebook, I want a new one, I will just pick the lab notebook and go ahead and say, oh, this lab notebook was from this period to that period. But the student usually put their lab notebook, they do not put the number, but when they pick the second lab notebook, then they go ahead and put, oh, this was my lab notebook 2, or this was my lab notebook 3, and stuff like that. And we do not just do that in research lab. In teaching lab, we do that as well. We push our students to kind of trying to do the same thing. We give them the lab schedule, but we ask them to actually put it on the back cover of the lab. And then we ask them to have their own table of content, just like any other lab notebook, we have their table of content, just to start kind of pushing them to learn how to keep lab notebook and, keep them in the way that a researcher actually do the lab note. So this is an example of teaching lab notebook from one of my students. So that's kind of what the first page of the lab notebook should look like. And you can see that the label, the page, they actually make sure that you can just pick the table of content and go exactly on the page of experiment and look at the experiment they run on that day and things like that. So that's kind of the idea behind this kind of teaching we actually do here. So like I said, a date and title each experiment. So when you start an experiment, please put the date, put the title. Most of the time in the lab, we just have a code for an experiment, GSSO1. We know exactly what that is, so that's a title, but you still have to date the experiment, what day you're doing it. And sometimes people will put time. We put time at what time the experiment was started so that we can put the time at which we stop it, just to know how long. has been between setting up the experiment and actually stopping it. We put in the protocol, we put in the calculation, we put in the region, the equipment used during the period, we put in the observation, anything planned and unplanned. That's very important. Not just the thing that you was helping that will happen. Please also the thing you didn't expect that will happen. Stay true to what the experiment is trying to tell you. In chemistry, we always say molecules are trying to tell you something. It doesn't matter when you wanted them to do, they end up telling you what they want to tell you, and you have to be listening to what they want to tell you. So it shouldn't be just what you expected. It's also what you didn't expect. Actually, most of the time, serendipity is actually at the heart of discovery in science. You're expecting something and something completely new show up. And that's sometimes way more exciting than actually what you were expecting. Raw data should be in there and they should be permanent. They should be set in the way that permanently staying there. I'll show you a couple of examples in a couple of slides. And then if you have other data, and that's usually the case in chemistry, when I run the experiment, but when I run the reaction in the lab, but most of the characterization I run on different machine, those I will print data from that. I'll show you a couple of examples. And I'm going to make sure every time that each data I got is cross-referenced to that experiment. So if the data is not directly in the lab notebook, please make sure that they are cross-referenced correctly so that we can associate that data to the experiment. And then always have some conclusion. And those conclusions should be very specific rather than be just your opinion or your feeling at the time. It should be kind of what happened. The reaction did work, the reaction didn't work. Don't put anything like, oh, the reaction will never work. That's pretty much an opinion. You don't know that. Draw your conclusions straight up from the experiment you run. The reaction didn't work in this very specific condition, or this thing happened, this thing turned yellow, this thing turned green, or whatever happened, please put it down, and that might be good information in the future. If multiple people are using the book, everybody should actually reference their entry. So we should know who put which entries in. And this is going to be very important later, as we talked about. If in case of dispute or fraud accusation, it's very important to know who collected which data or things like that. Or later, if you want to attribute credit for discovery, we should be able to easily attribute the credit to the person that actually put that entry. So if more students, and sometimes in the lab, many students use the same lab notebook, so then they should actually identify the entry. So what does that look like in practice? It looks something like this. And this again, I borrowed this page from the Columbia, the left page right here, I borrowed it from the Columbia tutorial. And they just have this, pretty much this kind of dating page, a random experiment. I don't think it's a real experiment. Then they show there what to do. If you make a mistake, please do not black it out, do not white it out, just cross it over, just put a line through it so that it's still readable, but put what you meant near it. And this is just to show that you didn't try to cover up something, that everybody can still read anything you put in the lab notebook, but make sure that you cross it out so that they know that's not the one you use, the correct one you use is the one there. It's usually a common practice in chemistry to label the chemical you use, the batch of chemical you use, because they might be slightly different. Some of them might be contaminated, they might not, that might impact your experiment later on. It's actually kind of good practice to put those things in, just in case someone say, hey, but we use different acetone and we didn't get what you got. It might be that something in the acetone you use specifically impacted your experiment in the way you didn't actually think of, and that's actually good information. And this is one of the advantages of having a book, stitch page book, as opposed to loose leaf binder, because you're not supposed to keep a blank in your lab notebook. You're literally not supposed to do that, and that's for authentication. So when you have loose leaf, that take that away, because you could have add another page. It's actually recommended for scientists, if you have space that you have left, either you scratch it off or you put a cross through it so that nothing can be written there. And importantly, sign your pages at the end of the day and hand date it. And you can see the date at the top and the date at the bottom are two different things. I started there, but here I'm done. Why? Because you can have the same date a couple of times. I put the date over there and keep my experiment going on the other page. at the end, I would say those 2 pages I did them the same day. So that's kind of the idea right there. And this is a couple of examples from our own lab. I kind of pick a couple of things we do here. Those things we put in, you can see how we kind of put data neatly in there at the end. Sometimes put the day, the page, all those things. And here I have a blank there, shouldn't be there. But again, undergraduate student, but that should be crossed off. But what I want to show here is that we actually stick even the TLC and other things we found right there in the lab notebook. We do not store them somewhere else. We actually literally tape them there so that we can even look at it when we come back to it. And as I also mentioned, sometimes we run the experiment and actually run the data on something else. Here, I'm showing the experiment to the left and to the right, and that's my right. I don't know how you're playing your screen. Right here, I'm showing the experiment, but on this right here, I'm showing the GCMS run from that experiment. We just tape the GCMS on the left page. So basically, right there to kind of cross-reference it to the experiment. In our lab, we do not store it in the binder somewhere. No, we actually keep them in the lab notebook together with the experiment. That's kind of the practice we have. We just cross-reference our, put the reference or any additional data we collected right inside the lab notebook. So, a couple of tips for this is physical paper lab notebook. Use an ink. Don't use a pencil to write your lab notebook. Use ink pen because pencil can be erased and all those kind of things. We already talked about that several times. Authentication of lab notebook is actually very important. Write as you go. And don't write on a scratch paper. If you write something on a scratch paper, please tape that scratch paper in your lab notebook. Just go ahead and tape it in. Don't just say, I will reproduce it later. No, put it in. That's what happened. Do it as you go. Trying to be actually as accurate as possible. That's kind of very important. In case of error, we already talked about that. Just put a single line into it and write the correct information near it. That should do. Never white out or black out to fix error. That's really not a good practice in lab notebook. That's kind of, it feels like a sign of cheating, even if that was not your intention. So please be aware of those kind of things. And complete your entry in consecutive pages order. So if I start an experiment and keep going, don't skip a page in between. Don't skip a space in between. That's still very important in case you're looking at your lab notebook later. Keep it continuously until you finish that entry. Begin new experiment on a new page. So if I finish this experiment and I want to start a new one and I still have a blank, I will go ahead and cross out that blank. If I'm not going to cross out that blank, I will have to put maybe those TLC I run on any other data I collected on that place to close that page up. But the new experiment is actually advised or actually encouraged to start a new reaction on the new page. And that's going to be a new entry that you can follow through. Avoid empty space, we talked about that. If it's not avoidable, of course, we say to cross it off and just cross the unused one. Do not remove pages from your lab notebook. We understand already why. It's because, and that's why I stick paper physical book. It's actually very, how will I say, favored by scientists because help you kind of keep that continued idea of a lab notebook on tempo in the lab. So basically, please don't remove a page. If something goes wrong on the page and you don't want to write anything on that page, it's just easy to cross it off and keep it there. Then the page will be there when somebody look at it. Please sign at the end of each page. We talked about that. Some institution will require that you have either your lab mate or your supervisor to actually co-sign the entry. You see this a lot in chemical industries where basically every week or every day you bring your lab notebook to your supervisor to sign it with you to say, I acknowledge that you did this and this and things like that. In academia, I look at my student lab notebook maybe once a week and kind of, I sign in the page with them in there, but again, in the industry, it's actually very, very strict things to do, and that's something that a scientist should actually kind of get use of the one. Lab notebook, it's not. What is not? Lab notebook is not. Few things that lab notebook is not. Many people think lab notebook is a journal. If you think a journal in the sense that you put everything you're doing, any conversation you have, any other, I'm in the meeting. You cannot be in, please. Sorry. If you are, if you take a lab notebook, like something like a journal, something that you put everything that go your head, or have this conversation with my supervisor and stuff like that. That's not what a lab notebook should be. A lab notebook should be something you put things specific to your experiment, things that you're running, things that have direct impact on the experiment. If you're going to put a thought in there, it has to be something related to the experiment you actually set up. It should not be something, it should be clearly for the experiment. It should be clearly for what you're running. So as I said, it shouldn't be a record of communication. No, I discussed this with my lab, my PI. I come to the lab. No, please, in the lab, if you have a discussion with your PI, come back and write exactly what experiment your PI wanted you to run in there. And it should not be a place to compile lab manual. Like, hey, one day I might use this experiment, let me put it in there. No, please put in only the experiment you're using. Some people think you should put hypothesis, goal, and specific aim in the lab notebook. I think for many, from what I think and what I believe is that if you need those information, you should have a separate lab notebook where you keep those kind of things. Things like, oh, this was a hypothesis, this is a goal. Because the lab notebook here should be basically very specific to what you're doing. Specific aim. I know when we write a paper or we write a grant, those things kind of tend to show up, but that's a bigger picture of what you're doing, and not necessarily, because big picture might be split into 20, 30 small experiments or 3 different projects. And it might not be obvious or directly related to the experiment you're running at the time, although in the long run, the two things come together. It's also a place for background information. I'm not going to go here and start, putting all my literature and all those sort of things in there so that I can actually keep them in one place. Some people like, I want to keep them. Yeah, if you want to keep them in one place, please try to write them in your own lab notebook, like your take home, or I run all those, I want to summarize them in my own way. If you're going to summarize them in your own way and different from exactly what you do, you're simplifying it, you want it to be more understandable to you, please write that in a separate lab notebook for you. Many graduate students tend to keep this kind of separate lab notebook where they collect their thought. And I'm going to talk about that later. And this is not an official lab notebook, because your official lab notebook is when you wrote everything in the way you did it, in the order you did it, and clearly as you did it. But this one I'm talking about is just something, if you're going to get home and collect your thought and compare it to another experiment and look at it from different background or different perspective, you can actually summarize that for you and take it home. But that's not a place for your lab notebook to do those kind of things. All right, I'm going to quickly here for a couple of seconds talk about electronic lab notebook, and it's making it's becoming mainstream. Actually, since COVID, it's even becoming more evident that people are using electronic lab notebook. And basically, electronic lab notebook, it's something either on the drive or on computer or connected computer. We're going to call it electronic, or let me call it electronic for now, and then I will kind of get to it later. So, electronic lab notebook. What are the couple of things you need for a good electronic lab notebook? The electronic lab notebook, it's easy and to write in, because you're tapping in, you can save it there. You can literally retap something, you can erase something you put and re-put it. It's easy to take note because you're basically tapping. It's easy to organize because you save it in the order you want. You save it on the side. I will show you an example of that. I took this couple of advantages of electronic lab notebook from the tutorial from Columbia University. And I put here in quotation secure and easily navigable. But because they did this around I think it was 2009, and we know that the security of electronic lab notebook is becoming more and more difficult. But at the time, it was probably really secure when you thought of it. You never thought that somebody would just start writing in your lab notebook as writing it or when you're gone. But I put it in quotation because we're going to talk about that. But it's easy to navigate, as we know, in a digital the word I was looking for earlier was digital lab notebook. Electronic and digital are not necessarily the same thing. You can have your electronic lab notebook right in your computer. Digital mean more like it's shared on the drive somewhere that many people can easily access it. No, digital mean you have in your computer in the digital file. Electronic mean you have it that you can share it and many people can actually use it at the same time. All right. This also allowed embedded pictures, so you can literally put pictures in at any time you want. You can literally put whatever data. And actually, I'll show you an example that you can actually be writing your lab notebook and use, let's say, a software to generate picture and just put it in. You Excel file and just add it in and have a graph and anything like that. It makes it easier to have all your data in one place and things like that. Easy to link between pages, so you can just connect them easily. A lock notebook page, because basically when you log in, the computer can quickly tell who logged in at what time and things like that. It's easy to do that. Secure login can help for those things. It keeps an audit trail. So basically, whoever put the information in, that can easily be retrieved, and we can easily know at what time and where they put it. It allows witness signatures. Somebody doesn't have to be in the lab with you to sign on that. They can just log in from wherever they are signed. Ability to easily export data, that's actually very important. Let's say you already have that Excel file and all those pictures. When you're writing a paper, you can literally just pull them and put them in the paper as you wish. But as we know, they have also, I'm going to quickly show you, they have also their disadvantages, as I will talk about. But this is an example I just picked from a commercial page. This one is from Grab Hacker, and this is the advertisement for their electronic lab notebook. And you can see that they label all different places, how you can sample out and track your experiment, how you can have your table of content. You can search information across all your content easily. You can link file if you want. You can link other pages. You can link quick look. You can actually do a lot of things on this. And you see, the other thing with lab notebook is that you should never remove lab notebook from the lab. But electronic lab notebook allow you to actually, even when you're home, you can access it and still process data and do things with it. And many people can work in the same lab notebook at the same time from different places. And that's actually the main advantages of having electronic lab notebook. I have another example of electronic lab notebook here, where you can see that you can add graphs, you can play with different things, use software from your computer to add different things as you go. And you cannot do that easily with the normal lab notebook, because then you will have to go in the computer, do that, cut it up, and come and paste it. So this is what have been thinking, or have been thought to be, or have been provided or put forward as the main advantages of using electronic lab notebook. So those are the two examples of electronic lab notebook I put in there. But again, like I talked about earlier, the security of this is becoming more and more difficult. I mean, we're seeing hacking all the time. People just take all your data. And that's become a problem, because if that's the only data you have, and then you don't have it no more, or sometimes you save a completely nice pictures and everything, and the next day you cannot open because the document have been corrupted, and then you cannot longer get to it. And the future, it's also the problem with that is the compatibility of software. You have those nice picture you store in your computer using a version of software, and 3, 4 years, 5 years down the road, that version of software is gone, and you have a new version that can no longer open the data that you saved a couple of years back. So those are the disadvantages of having those having electronics lab notebook. But it depends on what the company want to do. It depends on what the firm priority is and things like that. People will tell you now that many people are working from home. This is a very good way to actually have a group working on the project, having data that they can share across platform and things like that. And I agree with that, but it's not all good. Everyone has their own disadvantages. All right, I'm coming towards the end here. Lab notebook, advantages and disadvantages. We already talk about those. This lab notebook, when you have a bound lab notebook, you cannot easily lose pages. It's easy to authenticate. The disadvantage is that difficult to copy. Uh, difficult to organize things in that lab notebook. Difficult to cross-reference things. I showed you earlier how we take things in the lab notebook to be able to cross-reference them. If you're using a binder, of course, you can organize very easily, but you cannot authenticate it easily. So you cannot authenticate it very easily. The computer lab notebook, we talked about how it's easy to organize, how searchable and all those kind of things. But again, you're gonna have file can be corrupted, software compatibility, potential of cyber attack, and all those kind of things become actually a real threat when you're using those lab notebooks. So for the two last slide going here, I'm just going to talk about who owned the lab notebook and few ethical consideration when you're writing things in your lab notebook. Who owned your lab notebook? Well, the institution at which the experiment was conducted is the owner of the lab notebook. So if you're working for a company, they are the one that have your lab notebook. You're working for the university owns the lab notebook. You're using it, but the company for which you're working on the lab notebook. As a researcher, your responsibility is to maintain the lab notebook that everybody can use for yourself, for the PI, for the future of the lab. So even if you're not owning it, remember that you're writing it for those that are going to use it. But when you come down to ownership, that's for the most of the time, this company doesn't care until they have to care about it. But we shouldn't lose the fact that we shouldn't forget that they actually the owner. Lab notebooks should never leave the lab. So that's actually one of the things. And we talk about physical lab notebook. You cannot take them home. If you want those, and I pointed out earlier, some institutions will allow researchers to have a secondary lab notebook or a journal for daily summary and key information the researcher might need, like away from the lab. But I know there are institutions also that do not allow that because runaway information, you might actually summarize everything, maybe for a patentable idea. You just put in a lab notebook, take maybe a train home and forget it in the train, and that information is gone. So some institutions are really, really strict about taking anything from the lab. You want to work on something, they might require you to actually come in place and look at the lab notebook in place. So it just depends on the institution. Intellectual property, the lab notebook is your proof of, you're the one that has created the idea, invented the concept, and things like that. So that lab notebook is usually proof of that. And the entry page as such should be signed and dated and have personal witness of the invention. Please make sure that your information is credible, that somebody can actually testify of the fact that you're the one that have the information first. List the co-inventor, the people you're working with, and unless it's a waive, the university of the company you work with is also the owner of the intellectual property or the right of patentable invention of discovery and any technology associated with if the experiment were run in the facility of that firm of the industry. So please be aware that all research you do at the university of a firm, they actually the one that has the right over the patent for those information. Lab ethics, well, when you come down to lab ethics, please it comes down to be honest. All data needed have to go in the lab notebook, even specifically, even those that didn't work. Please don't just think if it didn't work, it's not important. Everything successful and unsuccessful experiment should be fully documented. Pages should never be removed. We talked about that already several times. Please don't try to remove anything. Record facts, not opinion. We talked about that. Please stay with the facts. And as I said at the top, be honest. Just trying to have in the lab notebook what really did happen. Trying to put them as accurate as possible. Trying to not to alter them at any point. If you have to rectify something, and since we're known to rectify things, please take a new page and write your rectification there. If something you later realize something you thought was right is not longer right, you have the right to make a mistake, but you don't have the right to go back and change that. You just have to create a new page to actually correct your mistakes. And I think that's pretty much everything I wanted to talk to you about today. That I'm gonna again say that the data I present today, I actually have them from those four major references, and I added a couple of one and I reference them as I go. And yeah, I'm glad again that I was able to look into this because I learned a lot in the process. I did a lot of things that I didn't know myself when I started. And at the end, I'm like, wow, I should have done this. And I really hope you might find those information useful as I did find them useful. And please, I would try to answer any question I have. I don't guarantee that, as I told you. I picked them from many of those things. I will tell you what my understanding of what I read preparing this has been. And I really thank you for your attention and being here with me today. And I thank you, Dr. Hall, for inviting me to doing this. It was really, really eye-opening for me. I tell my student this morning that we're gonna have a group meeting at the beginning of next semester, and I'm gonna give you this very presentation because it changed a lot about how I see the lab notebook. And I thank you all for your attention, and please let us have a discussion if we can. Thank you so much.
Dr. Fotie, thank you very much. So, oh my, I can see that the lab notebook is an orientation course within itself. And I think that's what you basically was telling us. This was eye-opening for you. So I know it will be eye-opening for your students as well. And also I can see it's a living, auditable legal document. And in this age of cyber attacks, hacking, etc., and as a lawyer, I can see the pen and ink lab notebook taking precedence over the electronic notebook. Now, that's just my interpretation of it, because that electronic notebook, like you said, it has some use to it. But for the most part, me being a non-scientist, I can see as an attorney where I would promote the pen and ink notebook over the electronic notebook. Here's a thought, and I want your input on this. What would you think, or is it possible to do a hybrid notebook? Meaning, I saw when you had your different examples of the laboratory notebook, things were handwritten in the notebook. And you also showed us where people or the student researchers, the PI, or whomever could add things to the notebook, like staple something you found or tape something you found. Is it possible to perhaps create your charts and graphs electronically and insert those, tape them down, staple them down, whatever the proper way would be, to the pen and ink notebook, and thereby creating a hybrid notebook? What are your thoughts on that?
Yeah, I think that's a good question. I'm going to just point out, in our research group, we have a drive. We have a shared drive where we actually, the shared drive, initially, it was an initiative for many publication institution where you can have data that are not directly from your lab notebook stored somewhere where you can actually refer to it. Like, hey, if you really want to see the raw data from the experiment, you can go in the shared drive and actually have access to them and maybe process it yourself. Mm-hmm. And the idea was there to avoid initially to avoid fraud, like not saying, oh, I have this experiment done, but you alter the spectrum at the end. But if you give someone the raw data and they process it themselves, there's no way you can alter the raw data. And that was the initial idea. In our group, we have that now where we store the information. We store those secondary information, like the one I show you in the lab notebook. Mm-hmm. We still have a copy electronically in our shared drive where we can access. I can access it from home and things like that. And if a student do like a chart, they will actually upload it in that drive. Then we all can see the chart in there. And when we put it in the drive, we cannot remove it. Anything in the drive should stay there. If you're going to change it, Jay, you can bring a new copy of it, pretty much. So it's almost like, and I haven't thought of it as a lab notebook now, that it looks kind of a little bit like a lab notebook in the sense that we have, and then we have different files for each experiment. That's what we do. And if you go in that file, we're going to find, you do not find a lot of notes about how the experiment itself will perform, but you find all the data related to that experiment. So I think that's possible. But when I look at the way the lab notebook, the one commercialized right now is set up, it's almost set up to be a platform on its own. And that's the thing, they want to make it like, hey, you can do everything here, but people can still do a lot in the lab. and transfer it. Now, if they're gonna be kind of a repetition of each other, you can quickly see how scientists not gonna like it, because you're gonna spend all your time doing a paperwork rather than actually running an experiment. And many scientists do not really like that. You like to be looking at your scale and write the data down as you go. And I think if we're gonna do that, we have to kind of be mindful of what is easy to keep in the physical lab notebook and what is easy to keep on the computer. Those computer generated data, easy to store them electronically. But when you're setting up an experiment in the lab and you're handwriting, it's probably easier to actually just handwrite it.
Okay, so I have another observation and or question. So during the presentation, I realized that, and you correct me if I'm wrong, I realized that it appears you spoke of one lab notebook. So if you're doing a research project, all the students and the PI capture their information in one notebook for that particular research project, as opposed to in a class, a research class, where there's a lab and a lab notebook, each individual student keeps their own lab notebook. Is that
yes, it's true and not true at the same time.
okay?
Sometime in the lab, most of the time, each student have their own project. In which case they have one lab notebook. And most of the time, I will be the only other person going in that lab notebook for that student. So if I have a project and I split it into different parts, this is your part, then you have a lab notebook for that part, and that only that part goes in. And but sometimes I might have two students doing the same project. Maybe you want it to go faster, maybe it's too much for one person. If that's the case, those two students will be using exactly the same lab notebook. So the lab notebook is not just specific to a student, it's specific to a specific project. Most of the time it's for a project. And if a student graduates and the project is still going and that lab notebook is not full, the next student comes in and pick exactly that lab notebook and keep it going. So it's more of project kind of oriented than student oriented kind of approach. Yeah.
Okay, great. So I heard you say early on that you work with high school students. So
yes.
You think this would be a beneficial orientation or mini training for high school science teachers about the laboratory notebook, so the students will be familiar when they come into a college setting?
Yeah, I actually think, like I pointed out, I think everybody that want to do science should do this. Great. I wish I did this a long time ago. I mean, and I've been doing lab notebook forever, maybe for 20 something years now. And I'm going to be honest that we have this real strong culture at keeping a very good lab notebook. Right. But we never actually go beyond that and just look at why do we do all those things? Why do we actually keep the lab? Why do we do the things? Well, we keep it the way we keep it because we're told to do that. Was trained to do exactly that, but I was never trained to understand the rationale behind why those things are actually important. And I realize now that when you actually understand rationale, I show you one page from my undergraduate lab notebook when there is a blank, and I didn't really care because I just thought to myself, it is just a blank. But now that I finished this, I'm like, no, it's not just a blank. Right. It just shouldn't be there, because something else could be added there later. And then you see, if you have a lab notebook with a lot of blank, how do you know that you wrote that at the time you say you did write it at the time? And that becomes something I actually never thought of. So anybody that is training students should be aware of this. And the earlier, the better. And I'm pretty sure that if I didn't know that doing research for 20 years, I'm pretty sure many teachers probably do not know that. And I really think maybe it would be a good training, like for everybody doing research and keeping a lab notebook. Well, this may be a Board of Regents grant that we can write, Dr. Fotie, and get everybody trained, get the science teachers trained on this. We can actually do that. Thank you so much, Dr. Fotie, for sharing your knowledge and the wealth of information regarding the research lab notebooks. That concludes our webinar this morning, and we want to thank you for your attention and your attendance. Have a good rest of your day. Goodbye.